Hello dear students, welcome to the video tutorial on cryptography. So in today's video tutorial we are going to discuss about the X.509 certificate. So already we have seen what is X.509 certificate, what are the different versions. So all these formats we have seen, certificate formats. So in today's session we are going to discuss about how to obtain the digital certificate and how to revoke the digital certificate. So here we are talking about X.509 certificate. So this is the first thing that we need to obtain the X.509 certificate. So any user can verify a certificate if he or she has the public key of CA, that is the certification authority that issued the certificate. See, when we know that, see, each of the users, or if you want the security, consider he is the user A and user B. So if they want the digital signature of A, or if they want the certificate for the security, they need to contact certification authority. Okay, so suppose consider A and B both are contacting a security provider or a certification authority, what we can call it as X. Consider X is a security certification authority for A and B. So for A, what X will do is X will send the certificate, and for B also X will send the certificate. So what certificate contains, you know all these things, what certificate contains. So already we have discussed what is there in the certificates. Okay, so it provides the digital signature. Certificate is having the digital signature, and we know that how this digital signature can be obtained. This digital signature can be obtained by encrypting the plain text by using private key, and decryption is done by public key. Okay, so this is what we have studied for digital signature. So here what happened? See, when X is providing a certification to A as well as B, X will encrypt that certificate by using its private key. By using its private key, X will encrypt that certificate. When that is issued by A and B, since this A and B is connected to X, okay, so X will share the public key. X will share the public key for these two connected users, because these are connected to the certification authority X. So X will share the public key to this A and B. So by receiving this public key, what A and B will do? A and B will decrypt the certificate and it will check the digital signature. It will check the digital signature after decryption, because encryption is done by X private key. So this X will share the public key with this connected users. So A and B are the connected users, where it will receive that public key, and by using that public key it will decrypt the certificate. Okay, certificate is encrypted by private key, now it is decrypted by the same public key, X public key. So now it will verify the digital signature. Digital signature is verified. So that means A as well as B are received or have received the same public key. Okay, the same public key, and they have followed the same procedure to authenticate the digital signature of its certification authority. Okay, so I hope this point is clear to all of you. So you can see here, any user can verify the certificate. Okay, A also can verify the certificate, B also can verify the certificate if he or she has the public key of certification authority that issued the certificate. Okay, A can also verify the certificate, B can also verify the certificate, provided this A and B has to have public key of certification authority. Who is our certification authority here? X is the certification authority. By using public key of X, it will decrypt the message and it will check the digital signature. So this is how the authentication takes place between the user as well as the certificate authority. Since the certificate are unforgeable, we can't do the forgery. Forgery is not possible here. Okay, because the digital signature of one CA is different than the digital signature of another certification authority. If you want to decrypt it, you need to use its public key only. So for decryption, you need to use this certification authority's public key only. This certification authority and this certification authority will have different public keys, right? So we can't forge it. We can't do the forgery here. They are simply stored in a directory. So certificates are stored in a directory. This X.509, it's a certification directory. It will store all type of certificates. The directory entry for each CA includes two types of certificates. Okay. So when we enter the certificate in the certification authority, so there are two types of certificate that we can store or we can enter into the directory. So which are the two types? One is forward certificates, another one is reverse certificate. What is forward certificate? You can see here the certificates of X generated by other CA. So you can see in the diagram here, this is forward certificate. Here you can see here X is a certificate authority for C as well as A. C and A are the users, where X is a certification authority for this C and A. How we will write it? We will write it like this. C is the user, and for this C, who is the certification authority? X is the certification authority. The meaning is for this C user, X provides the certificate, digital certificate. Or this C is digitally signed by X. This C is digitally signed by X. So that means this is the certification authority and this is the user. So similarly for A, how we will write? We will write as A user is digitally signed by or digitally certified by X. Similarly, for this X, we have one more certification authority, that is W. So how we will write now? X is digitally certified by W. So if we write like this, that becomes the forward certificate. You can see here, this is the forward certificate, because here X is the certificate of X is generated by W. Okay, certificate of X, this X is certified by W, or certificate of X is generated by W. This is forward. What do you mean by reverse certificate? Reverse certificate is exactly reverse of that. That is, the certificate of this W is generated by X, or W is digitally certified by X. This is reverse certificate. Hope this is clear to all of you. Forward certificate, reverse certificate. You can see here, this is forward certificate, this is reverse certificate. Okay. Right. The user subscribe to a same CA can obtain the certificate from the directory. Okay. So if the user is having same security authority, certification authority, for example AB, for this both users, X is a certification authority. So they can subscribe or they can share the public key. X can share the public key to A as well as B, whereas A and B, if they want to communicate, they can communicate directly because it is under the same certification authority. So A and B can communicate very easily now. Okay, because it comes under the same certification authority. Suppose if the scenario is like this, where A's certification authority is different and B's certification authority is different. For A, the certification authority is X1. For B, the certification authority is X2. Okay. So A's certificate is obtained by X1. B's certificate is obtained by X2. So B is digitally certified by X2. A is digitally certified by X1. In such cases, we can't or directly communicate between A and B. Direct communication between A and B is not possible because A and B are under the different certification authority. Okay. So what A has? A has the public key of X1, whereas B has the public key of X2. Why? Because we know that digital certificate has been shared by X1 to A. What is there in the digital certificate? This digital certificate, once this X1 shares the digital certificate to A, what it has done? It has encrypted that certificate by using X1's private key. Okay. So this certificate is encrypted by its private key, and then it will come here. That certificate will come here. What A will do? A will receive the public key of X1. Since for A, X1 is a certification authority, right? So it will receive the public key, and after receiving the public key, it will decrypt this. By using the public key, it will decrypt the certificate, the digital certificate, and it will cross verify. It will authenticate who is the authority, who is the certification authority for us. So similarly, the same thing happens at the B. Okay. So where X2 will share the digital certificate to B. So how it will share? Encrypted format. It is encrypted by using X2's private key. Encrypted by using X2's private key because B is connected to X2. Now, B will receive that encrypted format and further B will decrypt it by using X2's public key. X2's public key. Then it will generate the certificate and it will authenticate that certificate by checking who is the certification authority for us. Okay. Now, since A and B are not directly connected, A does not know the public key of X2 because A is under X1. And B does not know the public key of X1 because B is under X2. Hence, no direct communication is possible. No direct communication is possible between A and B. Between A and B. So what to do in such case? Okay. So in such case, if you go for the communication will not happen. Okay. Because to happen, the communication between A and B will only happen when A has the public key of X2 and B has the public key of X1. Then only the communication can be happen. Okay. So how it is possible? You can see. So, but if two CAs have securely exchanged their own public keys, the following procedure will enable A to obtain the public key of B. So, A want to obtain the public key of B, then only the communication is possible. So, how it is possible? It is possible only when these two certification authorities has to exchange their public keys. Has to exchange their public keys. So how it will happen? You can see the procedure here. So A obtains the certificate of X2 signed by X1. So what A will do? So A will obtain the certificate of X2 signed by X1. So certificate of X2 signed by X1. Okay. So first this will do. Okay. Since now X1 and X2 are connected, so X1 can receive the public key or certificate from X2. Similarly, X2 can receive the certificate from X1. So since now it is connected, it can share the certificate, or it can also share the public key. So then what A will do is, A will obtain the certificate of X2 signed by X1. Okay, like this, as highlighted here. So A can obtain X2's public key from its certificate, because now certificate is there with X1. Because that certificate is now there with or digitally signed by X1. That means X2's public key is available to A now. X2's public key is available to A. So you can see here, so A can obtain X2's public key from its certificate and verify X1 signature on the certificate. So A can obtain X2's public key as well as it can verify X1's certificate signature, digital signature. So this is the first step. In the second step, A then obtains the certificate of B signed by X2. So this B certificate which is signed by X2, that is obtained by the A, because A has all public keys, all the certificate of X2, and X2 is connected to B. Hence, what A can do is A can obtain this certificate, this B's certificate, okay, which is signed by X2. Now A has a copy of X2's public key, so A can verify the signature and securely obtain B's public key. Okay. In this case, A used a chain of certificate. This is called as chain of certificates to obtain B's public key. To obtain B's public key, it has done all this procedure. So in the notation, it is expressed like this. So first what A has done, A has received X2 certificate which is signed by X1, and then A also has obtained B certificate of B which is signed by X2. So these are the steps it has followed to obtain the chain of certificates. Hope this point is clear to all of you. So this is another chain of certificate here. This another level is added here. You can see the hierarchy of security authority, certification authority here. This X has the users C and A. That means C and A has digitally signed by X. So you can see here we have both forward certificate as well as reverse certificate. And for X, W is the certification authority. So both forward and backward direction it is there. For W, V is the certification authority. For V, U is the certification authority. For Y also, V is the certification authority. And for Z, Y is the certification authority. And B is the user, which is signed by Z. So you can see here chain of certificates in both forward direction as well as reverse direction. Forward certificate as well as reverse certification is obtained here. You can see this forward. This is forward certificate, forward, and this one is reverse certificate. Reverse certificate. So here also you can see here. Here also you can see this is forward certificate. W is digitally signed by V, whereas this is the reverse certificate. And here also it is forward certificate, reverse certificate. Like this it goes on. Okay. So this is called as chain of certificates. So the next very important point is, after obtaining all this certificate, what is the revocation of certificate? So revocation is nothing but we will invalidate our certificate. We will invalidate our certificate before the expiry date. Okay, we know that every certificate will have expiry date, but before the expiry date of that certificate, we will invalidate that certificate for certain reasons. This process is called as revocation. This process is called as revocation. We will invalidate the certificate before the expiry date of that certificate. So what is the need of invalidating that certificates? Because that certificate has compromised the security. Once the certificate will compromise the security, then user can invalidate that certificate. So how it will compromise the security? It can compromise the security by doing these three things. You can see here what it can do. The user's private key has been compromised. You can see here what certification authority does is it has shared the private key of user. That's okay. That's wrong thing. That should not be done by the certification authority. So once such illegal things are happening, then we can invalidate that certificate. This process is called as certification revocation. Second one, user's certificate has been compromised. Okay, so certification authority, what it has done, it has shared the user's certificate to another authority. That is also not correct. It is also illegal. Then there is no longer certified by certification authority. This certificate, whatever we have generated, is not certified by the correct certification authority or valid certification authority. In such case also we can go for certificate revocation. Okay, the following format that we are going to use for the revocation of certificate. This is called as certification revocation list. These all parameters are called as certification revocation list, CRL. So you can see here what are all things are there. Algorithms, parameters, issuer name, update name, next update date, user certificate serial number, revocation date. So more number of revocation dates will be there. Then user certificate serial number, revocation date, algorithms, parameter, encrypted hash. These all are the parameters which are present in the certification revocation list, CRL. So each certification authority must maintain a list. Okay, this certification revocation list, CRL, must be maintained by all the certification authority. All the certification authority must maintain this. Maintain the list consisting of all revoked but not expired certificate issued by that CA, including both those issued to the user and issued to the other CA. All these things has to be maintained. Each certification revocation list, CRL, posted to the directory is signed by the issuer and includes issuer name. You can see here the date the list was created, the list was created, the date next CRL is scheduled to be issued, next update dates, and entry for the each revoke certificate. You can see here user's certification serial number and it entries revocation along with the revocation date. It is there. Every user must check the CRL before using the user public key. So before using the public key of the user, every user must check the CRL list. CRL list. Okay. So this is one of the example where I have taken for showing you the revocation of certificate. You can see this kind of while browsing certain websites or certain URLs, you might have found this kind of security certification issues, or it is said certificate error, navigation is blocked. You might have gone through this kind of errors. Okay, so this is certification error. You can see here everything is detailedly explained here. There is a problem with the website security certificate. So what is that problem? It is listed here. So you might have seen in the Internet Explorer somewhere, okay, around. So this is the revocation of certificate. This happens when certification is revoked. That certificate is not valid. When it is revoked means that certificate becomes invalid certificate. Once it is revoked, it becomes the invalid certificate. Okay. Let us see the public key infrastructure, PKI. So what we will study here, we will see what is public key infrastructure or PKI, what is the purpose of public key infrastructure, what is PKIX, PKIX elements, PKIX management functions, PKIX management protocols, working of public key infrastructure, and then real-time example of PKI. So this is the public key infrastructure. Public key infrastructure is a set of hardware, software, people, policy, and procedure needed to create, manage, store, distribute, and revoke digital certificates based on asymmetric cryptography. Okay, so whenever the word public key is there, that means it comes under asymmetric cryptography, because asymmetric cryptography means it will generate pair of keys. One is called as private key, another one is public key. Okay, so this infrastructure, public key infrastructure, it contains it is a set of hardware, software, people, policies, and procedures that needed to create, manage, store, and distribute and revoke the digital certificate. So all the digital certificates, what are there in the digital certificate, how to manage it, how to store it, what is the hardware configuration, what is the software configuration, what policies we are using in the certificate, all these things are there in public key infrastructure or PKI. What is the purpose of this PKI? The purpose of developing this PKI is to ensure the security. Okay, so is to, you can see here, enable secure, convenient, and efficient obtain of public key. So we need to securely obtain the public key, and it should be very convenient to obtain the public key, and the method that we obtain the public key should be very efficient method. So that's the main purpose of PKI, public key infrastructure. So what is PKIX? PKIX is nothing but public key infrastructure for X.509. It is called as PKIX. PKI for public key infrastructure for X.509 is called as PKIX, and this is the architecture model of the PKIX. You can see here what it contains. It contains PKI users, end entity, which is directly connected to the certificate or CRL repository. CRL, already we saw what is CRL. That's the certification revocation list. All this list will be stored, okay, by the CA, certification authority will store all these values. Then the end entity is connected to certificate authority, as well as it is connected to registration authority. Then this certification authority is directly connected to certificates, list of certificate which is stored in the database, and then it is connected to CRL issuer. Then it is also connected to certificate authority. Okay, so you can see the diagram. End entity is nothing but the end user. What is the job? He has to do registration, initialization, certification, key pair recovery, key pair update, and revocation request. All these things has to be done by an entity. Then it will go to certification authority. Then based on the certification authority, what it will do, it will first check the certificate in the repository. So if the certification is there in the repository, then it will cross verify that certificate, and that certificate will be provided to the certification authority. Okay. So first an entity, it will check it in the registration authority. So if the certification is available in the registration authority itself, it will not directly communicate with the certification authority. So this certificate which is there in the one certification authority will be cross verified or cross certified by another certification authority here. As you can see here, this is one certification authority, this is another certification authority. Here cross certification will happen. That means the certification of this certification authority has been digitally signed by this certification authority. So this is called as cross certification. So let us see the elements of PKIX. What are the elements which are present in the PKIX. So in the PKIX model, we have totally 5 elements as shown in the figure. So one is end entity, this one. Next is CA, certification authority. Next is registration authority. Next is CRL issuer. And last one is repository. You can see this is the repository. These are the 5 elements which are present in PKIX, okay, infrastructure. So let us see one by one what it will do. End entity is a generic term used to denote the end user or devices or any other entity that can be identified in the subject field of public key certificate. So this end entity is nothing but the end users, I can say. End users, or it is the end devices who wants to generate the certificate or who wants the digital certificate. These are called as end entity. Next, CA, certification authority, this one. The issuer of the certificate. So you know that certification authority will issue the digital certificate. The issuer of certificates and usually certification revocation list. We know that certification authority will also store CRL, certification revocation list. It may also support a variety of administrative function, although these are often delegated to one or more registration authority. Okay, so before obtaining the digital certificate, what user has to do? User has to follow many administrative functions like registration, then initialization, then certification, then key pair recovery, key pair update, and revocation request. All this functionality will be done by certification authority. All this will be done by certification authority. These are the some administrative functionalities that it will carry. And it will register the set. Once the certificate is created, that will be registered by registration authority. That certificate will be registered by register authority, and that certificate will be stored in the repository. You can see here certification publication. Once the certification is published, it will be stored in this repository. Repository is nothing but database. Each CA will have the database of certificates, and also it has the database of CRL, certification revocation list. So what is registration authority? This is an optional component. This is not mandatory. This is an optional component that can assume a number of administrative function from CA. Okay. And the registration authority is often associated with end entity registration process, but can assist in the number of other areas as well. So you can see here this registration authority is connected to the or associated with the end entity. Okay, but it can also assist with the number of other areas as well. Okay. Next is CRL issuer. So it is also optional component. So CRL issuer, what it will do? It will check whether that certification revocation list, whether the certification is present or published in the certification revocation list or not. Whether this particular certificate which is generated by certification authority, whether that certificate is present in this list or not. So that it will check. Then the repository. So the repository, another name is database, where it will store everything. So this is the generic term used to denote the method for storing. Okay, repository acts like a database or storage device. Storage of certificates as well as storage of CRL repository. CRL is nothing but certification revocation list. And this will be retrieved by end entity. So end entity, before it starts the registration and initialization process, first it will check this repository. Okay, so first it has to check the repository before it obtains the certification from the certification authority. So as I told, these are the management function of the certification authority or PKIX. So what are the management functions? So PKIX identifies the number of management functions that potentially need to be supported by the management protocol, which are, okay. So certification authority this PKIX will perform number of functions. Okay, so all these functions: registration, initialization, certification, key pair recovery, key pair update, revocation request, and cross certification. All this will be done by PKIX. So these are the functions of PKIX. Let us see one by one what it will do in each of this function. So the registration begins with the process of enrolling in a PKI. Okay, so registration process, it begins with the enrollment. Next, first user first makes itself known to a CA prior to that CA issuing certificate for that user. So what user will do? User is present here at the end entity. So first user makes a known to a CA. That means user will directly will check the certificate through the registration authority. Okay, prior directly going to the certification authority, directly going to this CA, what user will do? User will make the check in registration authority. So why user will check the registration authority? Because once the user started registration, his first registration will be done at registration authority. So hence he directly can't, without registration, he directly can't go for certification authority. So hence the name is called as registration process. Registration usually involves some offline and online procedure for manual authentication or mutual authentication. So here, once the user register himself for the certification, first the user will be authenticated. Mutually it is authenticated. So user will authenticate the registration authority, then registration authority will also mutually authenticate with the users. Typically the end entity is issued one or more secret keys, shared secret keys, for the subsequent authentication, used for the subsequent authentication. So once the registration is done, what is there with the end entity? End entity will have one or more secret keys. One or more secret keys that is used for the authentication purpose. Okay. So this is what happens in the registration, the function, first function. Next function is initialization. Before a client system can operate securely, it is necessary to install a key material that have the appropriate relationship with key stored elsewhere in the infrastructure. Okay, so before the operation, okay, before we start with the security operations, first it is necessary that we need to install the key materials in the relationship with the keys. Okay, with the keys which is stored in the infrastructure. Somewhere in the infrastructure, keys has been stored. Okay, so we need to appropriately check whether that key is stored somewhere in the infrastructure or not. For example, the client needs to be securely initialized the public key and other assured information of the trusted CA to be used for validating certificate path. So we know that this client should have the public key of certification authority so that it can decrypt the certification. Okay, already we know that the certificate which is obtained by the certification authority, it is encrypted by the private key of the certification authority. So in the initialization phase, what it will do is this client has to initialize, or client has to take the public key of the certification authority so that it can decrypt the certificate and it can validate the certificate. Okay, so this public keys, public keys of that certification authority may be stored anywhere in the infrastructure. In this infrastructure, it can be stored anywhere. So first client has to install it, or client has to take that particular public key for its next further steps. Okay, next, the third process or the third function is certification. We know that certification is the job of certification authority. It has to provide the certificate. This is the process in which CA issues a certificate for user's public key. Return that certificate to the user's client system and or post that certificate to the repository. So once this CA, it will generate the certificate and that certificate will be stored in the certificate repository. One copy will be stored here in the certificate repository. Another copy will be sent to the user. Okay. So where user uses the public key of the certification authority, then it will decrypt the certificate and it will authenticate the certificate. Next is key pair recovery. So here key pair can be used to support digital signature creation and verification, encryption and decryption or both. So why this key pair is required here? Here the key pair is required for digital signature verification. Digital signature verification. Okay, so key pair is required because here this uses, as we already have discussed, this uses asymmetric cryptography. Asymmetric means pair of keys will be generated, private key and public key. Since we are talking about digital signature, here what happened? The encryption is done by the private key and the decryption is done by public key. So anywhere if one key is missing, suppose for example, within some of the process, private key has been stolen or private key has been gone wrong. So we need a mechanism to recover private key or recover the public key, because encryption and decryption both has done by using private key and public key only. Okay, in certain abnormal situation, what happens? We may there are the chances that we can have the wrong public key and wrong private key, or public key or private key can be missed. In such situation, we should have the recovery process where you can recover our key pairs. Okay, this is what the key pair recovery does. When a key pair recovery is used for encryption or decryption, it is important to provide a mechanism to recover the necessary decryption keys when normal access to the keying material is no longer possible. Okay, so it is no longer possible to recover the message by our normal keys. Why? Because the normal keys may be turned into abnormal stages. Okay, so hence it must require that we need to recover the keys. Otherwise, it will not possible to recover the encrypted data. Yes or no? Because in some way, in some point, consider encryption is done now, but decryption is done by public key, but that public key is gone missing or gone wrong. So you can't encrypt or you can't decrypt the data now. So for that purpose, we need to have the recovery process. So what this key pair recovery allows? It allows you to restore the decryption and encryption key pairs. That is public key and private key pairs, because the backups will be created here. Backups will be there. From this backup, we will take the key pair for which is used for encryption and decryption of the digital certificate. Hope this point is clear to all of you. Next is key pair update. So all key pairs need to be updated regularly. Okay, once we generate a key pair for encryption and decryption, so we can't use the same keys again and again. Okay, because each time the certificate starts, okay, and certificate expires. Okay, there is a start date and there is an expiry date. So if the start date and expiry date, if one certificate expires, then you need to generate one more key pair for the another certificate. Like this, each time when the new certificate is generated, we need to update the key pair also. We need to update the key pair. This is very, very important. Once again this certificate is expired, again we need to generate a new certificate. Again, once the new certificate is generated, again you need to update the key pair. Okay, so this is what happened in the key pair update. And last one is revocation request. So we know that revocation, when the revocation happens, when we want to invalidate that certificate, we will go for the revocation. Why invalidating of certification is there? Invalidating of certificate happens because the certification authority compromises, or it turns into abnormal situations, or it compromises with our security. Okay, so then if we will invalidate that certificate, and that invalidate certificates will be present in the CRL, certification revocation list. So any abnormality we found in the certification authority, then we will request for the revocation of certificate. So then that certificate is compromised with the security. So what we will do, we will request for the revocation. Then it's a job of this certification authority to revoke this certificate, and that certificate will be stored in the CRL repository. Okay. Yes. And last one is cross certification. As you can see here, cross certification here in the process or here in the infrastructure. Cross certification is nothing but we need two certification authorities will certify themselves. Okay, will cross verify themselves. You can see here. So in the diagram, X1 is one certification authority, X2 is another certification authority, but it is cross verifying each other. Cross verifying each other is nothing but X2 will be digitally signed by X1, and as well as X1 will be digitally signed by X2. This is cross verification or cross certification. You can see here two CAs exchange information used in establishing the cross certification. A cross certificate is a certificate issued by one CA to another CA that contains the CA signature key used for issuing certificate. So you can see here, this is the cross certification where X1 is certified by X2 and X2 is certified by X1. Here also the same thing on X2 side. X2 is certified by X1, X1 is certified by X2. So both forward certificate and reverse certificate has been generated here. So this is called as cross certification. This cross certification is done because we should have to exchange the certificate from X1 to X2, both sides. Okay, right. So what are the management protocols that PKI uses? So PKI working group has defined two alternative management protocol. One is called as certificate management protocol, which is called as CMP, which is defined by RFC 2510. RFC 2510 is the standard. Like we have TCP IP standard, OSI standard, like that. RFC. Okay. Request for communication. Request for comment. Okay. So this is the request for communication 2510. It defines the certification management protocol, CMP protocol. So PKI service allows CMP client to communicate with it to request, revoke, suspend and resume the certificate. So why this CMP is used in PKI? CMP is used in PKI for to request, revoke, suspend and resume the certificate. We have another standard called as RFC, request for communication 2797. So this standard will define one more certificate management, that is called as certificate management over CMS. Certificate management messages over CMS. This is another protocol, CMS, certificate management service. Certificate management service. So this is like a message. And what is this certificate management service will do? It can do the encryption, decryption, sign, verify, compress and decompress the CMS document. So CMS document is nothing but cryptographic message syntax. Cryptographic message syntax. So this cryptographic message syntax, what it contains? It contains encryption, decryption, sign, that is digital signature, verify the digital signature, compress and decompress the CMS document. So these are the two protocols, PKI management protocol, that we are using. One is CMP, another one is CMS. CMP is done by, or CMP is defined by RFC 2510, and CMS is defined over RFC 2797. So this is the working principle, or working general working principle of public key infrastructure, that is PKI. As you can see here, so first, through the internet, we are sending the request registration. So all the functionality is mentioned here: registration, then initialization, all this mentioned here, you can see here. So we are requesting, that request will go to the registration authority. So registration authority will confirm the identity of that person, or confirm the identity by authentication. Then the registration, once it is authentication, registration takes place. So if it is okay, then it will go to the certification authority. So what certification authority will do? The certification authority will again return back, it will receive ID and password, and that ID and password will be shared to this person. Okay, user ID and password will be shared to this person. So RA, first it will send that registration to certification authority, that this is registered user, and after that what it will do, RA will send, okay, this RA will send the user ID and password to this person. So once he receives this user ID and password, he can install the software and he can generate the key pair. Okay, and similarly, so he can, you can see here, he can send the request for the certificates to the CA, because it is already registered, right? So now he can request for the certificate. So that is there in the certification authority. So certification authority will issue the certificate, and it will publish the certificate. That published certificate will be stored in the verification authority. This is VA, verification authority. Now whenever this client wants to communicate with server, this server will first check the verification authority whether that user is verified or not. Once it says okay, then only this server will be communicated with the client. So this is the overall working procedure of the public key infrastructure. Okay, so this is all about the PKI and other things. The next topic I will explain it in the next video. Thank you.